Hello, I am Joaquin. My teammates are Daniel, Hassan, Jack, and Sakib, and we are Group 6. We will introduce water rockets design to you. Objective. The objective is to design and build a water rocket that will stay airborne for as long as possible without damaging the egg inside. We use Unity simulations and SolidWorks to design and test our rocket, as well as reading the briefing document to ensure you have followed the instructions, and in the future, test our rocket in non-standard conditions.
A larger parachute area creates a larger drag on the rocket due to an increase in air resistance. This means that the descendant speed is much lower, since there is more drag slowing the rocket. Having a smaller parachute area means that less drag affects the rocket due to a smaller region being affected by high resistance. This causes the rocket to descend at a greater speed. Therefore, the terminal velocity of the rocket with a larger parachute will be lower than the terminal velocity of the rocket with a smaller parachute.
Stability. The stability of the rocket is its ability to continue flying without being disturbed. The rocket is more stable when the center of gravity is behind the center of pressure. Therefore, having the fins closer to the nozzle moves the center of pressure closer to the nozzle, which allows the rocket to be more stable. It also reduces the risk of rocket changing the direction mid-flight. Having the fins further away from the nozzle and closer to the nose increases the instability of the rocket because the center of pressure may move ahead of the center of gravity. Propulsion. The propulsion system of rocket has three parts: air, water, and pressure. When the rocket's water fraction is altered, the impulse varies. The rocket is filled with 40% water. Then air is pumped into the bottle, which pressurizes the rocket and causes the rocket to launch. The elastic potential energy of the air forces the water out of the nozzle, which provides the thrust. Impulses change in momentum. The momentum before launch is zero, therefore after the launch, the momentum needs to be conserved. So when the water is forced out of the nozzle, the rocket must fly in the opposite direction.
To achieve an optimal design for the rocket, we have looked at different aspects to see which design is the most suitable for us. A larger parachute will enable the rocket to land with a lower terminal velocity, which would prevent the egg from being damaged upon impact with the ground. Having the fins closer to the nozzle stabilizes the rocket and prevents it from flying out of control. The water fraction also affects the rocket. The optimal water fraction in the rocket is around 0.4. Having too little water will reduce the amount of thrust of the rocket, whereas having too much water will reduce the force of the thrust. The weather conditions will affect the rocket's launch and its terminal velocity. In calm conditions, there would be minimal interference, but in windy and rainy conditions, the rocket may fly out of control.
One of the most important things we have learned is the use of Unity simulations. We have explored different rocket designs and saw how it affects the direction and the stability of the rocket. We have also learned how the water volume fraction and the pressure affects how far a rocket can travel, and how too much of it can cause the rocket to not launch properly.